All right. Good morning again, guys. Again, this is Christian Janelle Mercado. I'll be accommodating you all throughout the webinar. While we are waiting for the others to enter our Zoom meeting, I will call on our very beautiful president of the Scopes or the Engineering Council. Are you there, Ms. Rocher and Reyes?
Yes, hello. Good morning, everyone.
Morning, Press.
Mara-
Good
Maraming salamat,
morning.
Tol, sa lubong na iyong pagbati. Good morning, everyone. Maraming salamat po. Ito po ang aming pangalawang webinar. Gusto ko lang din pong i-acknowledge ang ibang professor from other course, Amparo. And syempre po, sa iba pong professor po ng ating engineering, Sir Patio and Sir Alba. Sir Padilla, maraming salamat po from attending our webinar for today. Hello, Sir Mark. Hello. And syempre po sa ating department head, Sir Kel, and ating Vice President, Sir Camigla. Hello po, good morning. Nais ko lang din po i-acknowledge ang ibang school po na umatin po sa aming webinar.
All
Salamat
right.
po.
All
So
right.
thank you everyone. Please enjoy. Thank you.
All right. Yes, we will enjoy. We'll truly enjoy this webinar, guys. Like what Miss President mentioned. So we do store a lot of surprises for you today, guys. So please stay connected with us throughout the whole webinar. Okay. So again, if you haven't registered yet or we're not able to click on the registration link, it's available on the chat box. It's the very first message that we have coming from Miss Monique, which is our registration committee. You can actually click on there, so you'll be included in our raffle draw on the latter part of our webinar. So again, we welcome everyone. Dr. Camigla, thank you so much for your participation for today and through our faculty, engineering faculty. And also, we would like to acknowledge all our participants coming from different universities and schools. Welcome, guys. Welcome to Trimex Colleges. And actually, it's a webinar series. So we have this is our second webinar with our team championing professionals in the new normal, the world of computer engineering. And for today's webinar topic is Introduction to Fuzzy Logic and its Application with our resource speaker, Engineer Rhino Bilen Caldo, MPA, MSEECE. So while we are waiting for the others as well as for our resource speaker, if you have any questions, feel free to post it on the chat box. We do have a lot of our committee that will be answering and taking it down for you. And if in case you have questions on the middle of the webinar, you can actually post it on the chat box so we are fully aware. So if in case there will be a Q&A portion at the end of the webinar, so our resource speaker, Engineer Caldo, can be able to answer those questions. So we'll go ahead and park that for the meantime while he is conducting the talk. Okay. So again, we welcome all of you. Good morning. Good morning. Thank you so much for waking up early on this morning. I know some of you are just got home from their work, so we are truly appreciate your participation for today. And also, if you haven't take your morning coffee, you can actually grab one. Where it's still early for us to start the webinar for our resource speakers, so you can get your coffee, take a sip, and just sit down and relax. We'll go ahead and have fun on this webinar for today. Okay. Again, feel free to post your questions or any inquiries on our chat box. We do have a lot of our team to accommodate you. Okay. And yeah, while we are waiting, here is the program scheduled for today. So you can check it out. This will be our schedule for the entire webinar for today. All right, there you go. All right, and again, we are live through Zoom and Facebook Live. So, to our Facebook Live peeps, hello, hello, good morning. Thank you so much for participating. And if you wanted to, you can actually share this link, guys, to some of your friends, your family members, or to your colleagues, to your classmates. You can actually forward the link. The welcome to you participate to our today's webinar. Okay, so yep, we will prolong a little bit the agony. Okay, so well, we are waiting for the others because we would like before we start the webinar proper is for everyone to enter the Zoom link so they can be able to hear the entire talk for our research speaker, Engineer Reno Belen Caldo, with the topic introduction to fuzzy logic and its application. And again, just a reminder for those who haven't registered, you can actually check out the link on the chat box. You can register, so you will be included to our raffle draw. We store a lot of surprises for you today, guys, for the entire webinar. So, kindly stay tuned. Okay. So, if you have any other questions, again, feel free to enter, chat it on the chat box below. So we can accommodate it for you. Okay, we do have a lot of committee to answer all of your questions. All right. So while we are waiting, again, we welcome especially our VP, Dr. Rito Camigla, and to our engineering faculty. Hello, ma'am, sirs. I thank you for participating for our webinar. And also to those participants coming from different universities, thank you so much for attending our webinar. And to our professionals from other companies, computer companies that we have today. Hello, guys. Good morning, ma'am, sirs. Thank you for participating. So again, this is Christian Junel Mercado. I'll be accommodating you all for today. All right. So while we are waiting, just time check already 8:49. Thank you so much. It's early in the morning, guys. Right? Some of you I know are not that morning person, so you can grab your coffee, take a sip, sit back and relax. Okay, so right now we have 90 participants here in Zoom, and it's counting in Facebook. So we are also live at Facebook. You can share the link. You can check out the Trimex Colleges Facebook page. And also, if you are interested to the courses that we have at Trimex Colleges, you can actually check out on trimexcolleges.edu.ph. Thank you. And right now, while we are waiting for our resource speaker, so again, we do have our house rules, so we can conduct the webinar properly. We can understand it more and thoroughly. So kindly watch this, please, and take down some of our house rules, so we can have a seamless and understandable webinar. Check it out, guys. All right. Good morning again, guys. We are live from Zoom and Facebook Live. So if you haven't checked it out, if you wanted to share this webinar to your Facebook friends, you can do so. Okay. You can check out the Trimex Colleges Facebook page. We are live at Facebook as well. So in case they can be able to join us on Zoom, they can actually view view the webinar through the Facebook Live. So kindly check it out. You can share, so your FB friends can be able to um, have takeaways as well about this webinar. So again, if you have any questions, feel free to post it on the chat box. We'll more than happy to accommodate all your questions. And again, for those who just entered the webinar, feel free to register through our registration link. That is the very first chat from our chat box from Miss Monique Teñido. So you can be included on our raffle draw on the latter part of our program. Okay. So I think some of our distinguished guests already entered the webinar. We're just waiting for the go signal for that. So while we are waiting, here is the program schedule throughout the morning. Again, we truly appreciate your participation and your patience for standing by through from 7:30 up until now. Thank you so much for your patience, guys. We will be starting the webinar proper in a little bit. While we are waiting, you can check out the program scheduled on your screen. And again, for those who haven't registered, kindly click check on the link on the chat box. You can register right now, so you will be included on our raffle draw on the latter part of our program. We store a lot of surprises for all of you guys. For those who are watching on Facebook Live, hello guys from Facebook. Welcome, welcome. Good morning. All right. So I do have now the go signal to start the program proper. And without further ado, we'll go ahead and start the program by our opening prayer.
Lord, thank you for this day, for the presence of everyone in this call. For once again, we are gathered and given the opportunity to appreciate life and your words. Forgive us for our shortcomings and cleanse our hearts as we learn and live your words and example. Father, bless our endeavors, especially today's meeting. May you guide us in our discussions, and may you enlighten our minds in every decision that we make. Give us your grace that we may effectively do our parts for your greater glory. All this we ask in Jesus' name. Amen.
And this is followed by our national anthem.
pambansang awit ng Pilipinas.
All right. Good morning again. This is Christian Janelle Mercado will be your host for today's webinar, and we all welcome you to our webinar for today's topic is Introduction to Fuzzy Logic and its Applications. And to give us some opening remarks, I'll be calling on with Dr. Rito Camigla. Here are a short message coming from our VP of Student Affairs and Development Office. Let's what? Let's watch this.
I would like to welcome everyone to the new normal. Alam nyo, maraming pagbabago ang binigay sa atin ng pandemya ito. Mula sa kabuhayan at pati na rin sa kung paano tayo makikisalamuha. Lahat tayo ay binago ng COVID-19 pandemic. Subalit sa isang banda, ay may naidulot din naman itong magandang aral para sa ating lahat. Katulad ng pagpapahalaga sa pamilya, sa kung ano ang meron at iniingatan natin. Sa nakalipas sa 10 buwan, pinatunayan natin ang tatag ng mga Pilipino. Hindi natin inaasahan ang bilis ng mga pangyayari na halos lahat ay cashless na kung gusto mong kumain, ay magpa-deliver ka. Kung magbabayad ka ng bills, ay pwede na online. Shopping, banking, at kung ano-ano pa. Pero alam nyo, lahat ng yan ay napaghandaan na ng Trimex Colleges. Mula sa online payment, enrollment, records, and even the conduct of classes. At sa hapong ito, tayo ay magiging bahagi ng isang mahalagang gawain, handa para lamang sa atin. Namnamin ang bawat salita at bawat minuto at nawa ay matuto tayo. Maraming salamat at magandang araw sa ating lahat.
Thank you so much, Dr. Rito Camigla. And now a message coming from the Program Chair of College of Engineering, Dr. Kervin De Mesa.
So good morning to every one of you. So welcome to the General Assembly and of course the webinar series for Computer Engineering Department. So I would just like to welcome to all of you here for this activity. So I would just like to thank first to our scope officers, to the Faculty of Engineering, and to other guests, participants, and resource speakers for this particular webinar. A pleasant morning to all of you. So this webinar is not only intended for having a general assembly, but also in order to promote camaraderie to our students. The same manner, despite we are experiencing pandemic during this time, is to be able actually to give information or knowledge to make our students updated to the current trends in terms of technology. I'm actually welcoming you for this particular event because it will be a great and helpful tool for all of us to make ourselves updated to the different trends in terms of technology nowadays. Thank you so much for participating also for this particular event. This will be not be possible without your cooperations. That's why just sit back and relax and enjoy the different webinar series that we actually be given to all of you this particular time. So have a nice day to everyone and God bless to us.
All right. Thank you so much, Dr. Camigla and Engineer De Mesa, for the wonderful messages. And now we'll be going on to the webinar proper. To introduce our research speaker for today, may I call on Mr. Brian Christian Cappadocia?
Good morning, everyone. I'm Brian Christian Cappadocia, Computer Engineering of Trimex College. I'm so excited to introduce our guest speaker for today. Why am I excited? Because his talk is very relevant to all of us. She'll give us a talk about introducing fuzzy logic and its applications. Okay, so just a brief background. Our guest speaker for today graduated Bachelor of Science in Computer Engineering in Lyceum of the Philippines University, Laguna or LPUL in 2006. Also, he is Masters in Public Administration or MPA in Polytechnic University of the Philippines in 2010 and Masters of Science in Electronics and Engineering or MSc ECE in De La Salle University in 2013 under Department of Science and Technology or DOST Engineering Research and Development Technology or ERDT scholarship. He also pursued his master in engineering with specialization in computer engineering in Adamson University under Commission on Higher Education or CHED scholarship program. His, he took his leave absence for his Doctor of Philosophy in Electronics and Communications Engineering or PhD ECE. I'm sorry. Under the LSU scholarship to finish his third master's degree for vertical alignment. He worked as quality inspector in solutions, people innovation for 8 months. He worked as statistical process control or SPC, data management system or DMS, engineer for 3 years in Evident Philippines Incorporation. He took full-time faculty position in LPU Laguna. He also handled intellectual property coordinator position, research coordinator of COECS department and computer engineering program chair in the same institution. He was a former OIC education coordinator of ACLC College San Pablo for a year. More, more so, he was then He was then an assistant professorial lecturer 3 in De La Salle University, assistant professor 3 in Malayan College, Laguna or MCL, also known as Mapua University of College, assistant professor for in University of Perpetual Health Delta System. College Campus and Instructor 1 in Tanawan City College, Ergo. He is the CEO or president or project manager of Arcaldo Technical Consultancy Services founded March 19, 2017. He was able to present and publish multiple papers in the local international arena, including Scopus, EI, and ISI publications in respected journals. He published 22 Scopus Index Conference proceeding in IEE, Scopus EI, and ISI Journal Springer publications. As of date, he had more than 140 research publications, 57 research presentations, 52 seminars, conferences, conventions, workshops attended, 32 awards on 32 awards and scholarships, and 24 resource speaking and chairmanship engagements. He was granted funds from the OST and CHED for research presentation, publication, and dissemination. He was a recipient of several research presentation. He was a recipient of several research awards and organizing and chairing research colloquia, colloquia in the institution. He was the General Conference Chair of the National Research Conference on Computer Engineering Applications, or RCCEA, for 2015 and 2016, and Research Conference on Digital System and its Applications, or RCODSA, in 2019. He was invited as resource speaker to more than 10 universities and institutions in the country. He took chairmanship of different sessions and peer reviews in international conferences. Also, he is a technical program committee, or TPC, member and reviewer of the prestigious organization Institute of Electronics and Electrical Engineering, or IEEE. He is now holding the position of Model-Based Design Engineer in ROHM LSI Design Philippines Incorporated, or RLDP, since August 7, 2017, and Model Development Group, or MDG, Group Leader since July 6, 2018. He is in partnership with Multi-Axis Handlers and Technology Incorporation, AII TESDA Philippine, and Driving Assessment and Simulation Hub, or DASH, project team to design, develop, and implemented automated driver's assessment and driving simulator system to make the Philippines and Philippines a happy and safe place to drive in since September 2017. So without any further ado, let's give our guest speaker a round of virtual applause. Engineer Ryanel Belen Caldo. Hi sir, good morning.
Hello, good morning to everyone. I hope,
Morning.
okay. I hope you can hear me clearly. So I'll be sharing my screen for a while. Okay, is my presentation slide already visible?
Yes, sir.
Yeah,
Okay.
sir, it's visible.
Okay, so let's start. So again, good morning to everyone. I also would like to appreciate the committee behind this webinar, and of course, along with your professors and the teacher in charge, and to our attendees as well. Thank you so much for attending today's webinar. So I'll be the ones to be presenting to you today, and my topic is all about introduction to fuzzy logic and its applications. So thank you also to Brian for reading through my biography and introducing me properly. For our today's discussion, I will be focusing on the following topics. At first, I understand that most of us may not be familiar with fuzzy logic, so allow me to define it properly. And then we'll be dealing with a little bit history about fuzzy logic. And then later on, we'll be comparing fuzzy logic with other computational intelligence like neural network. And then how are we going to apply fuzzy logic, especially in control systems? And you'll be surprised that fuzzy logic can also be applied in other fields. Before the seminar ends, I will be also presenting to you some completed research works that I presented related to fuzzy logic. So that you'll be given some idea on how you can also use fuzzy logic, especially in your research works. The father of fuzzy logic is Professor Lotfisade from University of California, Berkeley, and he discovered this concept in 1965. According to him, people do not require precise numerical information input, and yet they are capable of highly adaptive control. So meaning to say, most of the current equations or formulas that we are currently using right now, it requires precise or accurate input. However, Professor Lotfisade tried to consider accepting noisy or imprecise input, and he devised an algorithm so that he can transform those inputs to its desired output. So that's where fuzzy logic comes in. So what is fuzzy logic? So fuzzy, from the term itself, it means not clear, distinct, or precise, or blurred. So the definition of fuzzy logic is that it is a form of knowledge representation suitable for notions that cannot be defined precisely, but which depend upon their context. So what does it mean? So most of our attendees today are engineering students. And I understand that engineering students have a lot of high-level mathematics, right? From differential equation to advanced mathematics and so on. But using fuzzy logic, you don't need to use high-level formulas in order for you to formulate your mathematical model. You only have to use rule-based systems, and then you can also solve the problem. So is it nice that we can use fuzzy logic for that purpose? I'm sure it is. Another terminology that we can use for fuzzy logic is rule-based systems. So we term this one as rule-based systems because these are systems that make decisions based on rules. So the very idea here in fuzzy logic is you really need to have a tangible rule in order for you to solve the problem. So we use rules that can be stated, and we can even term those rules as Chris rules or fuzzy rules. An example would be when we are dealing with inexact concepts like bigger, smaller, and faster. So it is easier to state the rules using this linguistic classification. However, we can also use numerical values for this purpose. But say, for example, a person which is taller is different with an animal which is bigger, but we can use the same linguistic classification, but it only differs in the numerical value. However, the difficult thing about the rule-based system is that optimization can be very difficult. So fine-tuning is very important in fuzzy logic, and most of the researchers are finding hard to optimize or to fine-tune their algorithm to use the fuzzy logic. So that is one of the difficulty that we can encounter when we use fuzzy logic optimization. Rule-based system, first, we needed to define the rules. So, but I have a note here that it is easier said than done because defining rules is not that easy. You need some experts, you need some experience from the operator or a person that is expert on that specific area of application, in which you can get some idea on how are you going to formulate the rules. Also, you have to consider, are the rules consistent? Because maybe you're able to define the rules. However, most of the rules are redundant, and some rules are just replicate of the other rules. So it is not consistent. Are the rules complete? Because maybe some of the rules may be missed. So make sure that the rules are complete, that you're able to cover all of the possibilities. So fuzzy systems is another concept or jargon that we use in fuzzy logic. Fuzzy systems define the fuzzy membership functions, and we have different fuzzy membership functions. So I'll be explaining it to you one by one later on so that you'll be clear about the different types of membership functions. Basically, fuzzy logic is a problem-solving control system methodology. So meaning to say, regardless of problem, whether it is in the field of engineering or in the field of business or whatever problem that you have, you can actually control them using fuzzy logic. And we usually use linguistic or fuzzy variables instead of numerical values. Because in the numerical value, what we actually use in fuzzy logic is we normalize the value, but we do represent them as linguistics. Example, this is an example of a rule. If the process is too hot and the process is heating properly, then you can cool the process quickly. So does it make sense? Of course, if the process is too hot and you are heating it rapidly, you have to cool it quickly so that it will be cooler. So that is one rule that we need to consider in fuzzy logic as an example. So what are the different advantages and disadvantages of fuzzy logic? Number one, just like any other computational intelligence, it mimics human control logic. So the way we think, the way we analyze, the way we solve a particular problem. So that is actually the same concept in fuzzy logic. And another advantage is it uses imprecise language. So as I have said earlier, so you don't need to have a precise input yet or an accurate input yet. You just needed to have a good rules first. And then inherently robust, and it fails safely and modified and tweaked easily. So what does it mean? So before you can actually implement in a hardware implementation of your prototype or design, you can actually test first using fuzzy logic. So once you see that the results are not good, you can actually change the rules and you can actually modify and tweak the rules that you've set. So you don't need to consider the risk, the failure in case that your system will fail eventually. Unlike prototyping, when you do already the prototype, of course, it requires cost already. And when it fails, then you needed to repeat it all over again. So that is the main idea about fuzzy logic. For the disadvantages, as I have said earlier, we needed experience from the operator or expert specifically for that field. And the system might be some complex or it might be a little bit complicated. So you also have to consider the complexity of your system. In order for us to understand fuzzy logic, I prepared here a sample traditional representation of logic. So as we know, the computer only understands binary, 0 and then 1. It is a machine code or machine language or binary code in other terminologies. And in that sense, we only use 0 and then 1. Okay? So an example here, we have here a snail, which is the speed is slow. The linguistic classification of the snail relative to its speed is slow. However, for the cheetah, the linguistic classification is fast for the numerical value of speed, which is 1. So we have two example here, snail and then the cheetah. So when we do the coding using C or C++, what we did is we actually define speed as Boolean because it's just a matter of true or false or 0 and then 1. And then we get the speed from the user. And then we analyze using conditional statement. In this example, if else, if the speed is 0, then it is slow. It is a comment here that it is slow for the linguistic classification. Else, if this particular condition is not satisfied, then it is fast. So that is the traditional representation of logic. Now, I will relate this one. How are we going to implement using fuzzy logic? Using fuzzy logic, so we don't actually use 0 and then 1, but we actually use values within 0 and then 1. Okay, so in this example, we can actually represent different animals this time aside from the snail and aside from the cheetah. And we can set numerical values for that specific animal. So we have here the snail. So slowest is the linguistic classification of the range from 0 to 0.25, and then followed by the turtle, which we classify as low with a range from 0.25 to 0.5. And then we also have here the dog, which is fast, 0.5 to 0.75. And we have here the fastest, which is the cheetah, from 0.75 to 1. As for the category or the sequence of these animals relative to their speed, so the slowest, slow, fast, and fastest, these classifications are correct, right? But if you put cheetah here as slowest, then it is not good enough. So that means that you needed to have some expert in order for you to help out. How are you to set the rules and how are you to classify the specific variable, or in this case, animal that you will be using in your fuzzy logic? So for every problem, it must represent terms of fuzzy sets. So what are now the fuzzy sets? So basically, the fuzzy sets here are the slowest, the slow, the fast, and the fastest. And these linguistic classifications can be also be represented using membership functions. If you will be coding this one using C++ again, so it's very simple. You only use additional and operator here to represent that if the speed is greater than or equal to 0 and the speed is less than 0.25, then the speed is slowest. So you're referring here to the snail. And follows for the turtle, follows for the dog, and the last, of course, is the cheetah. Of course, you can also use switch statement here. So actually, the good idea about fuzzy logic is we really don't care what programming languages are you going to use. You just needed to understand how are you going to use or implement fuzzy logic. In my case, I already use fuzzy logic using C++, using Excel, VBA macro program, using Verilog, and VHDL. Can you imagine? I have used that one using VHDL. It's so hard to code in there. I even use using Arduino IDE. Okay. And of course, you can actually use MATLAB Fuzzy Logic Toolbox. I even use that one as well. So regardless of the programming languages, as long as you understand what fuzzy logic is, you can actually embed that or include that in your research work. So basically, these are just the origins of the fuzzy logic. It traces back to ancient Greece. And as I have said, the first to publish the ideas of fuzzy logic is Lotfi Asder-Sadeh in 1965. So if you would like to study further about fuzzy logic, so I suggest you can read through the publications and articles written by Sadeh. And some of the fuzzy inference systems are actually named to Sadeh. So it's actually Mamdani and Sadeh. Those are the names of the membership fuzzy inference systems that we can actually use. Another is Professor Tosher Terrano in 1972, in which he organized the world's first working group on fuzzy systems. That's why we actually have, even right now, a lot of conferences or journal publications specific to fuzzy logic alone. I was even invited to review some of the papers internationally related to fuzzy logic systems for publication purposes. And I myself contributed to some research works related to fuzzy logic, even published in Scopus and Springer publication. And in the company application, we also have FL Smith and Corporation in 1980. They are the first one to market fuzzy expert systems. Actually, even in your homes, you do have a lot of fuzzy logic applications. If you have automatic washing machine at home, so it applies the concept of fuzzy logic without your knowing. So fuzzy sets, items can belong to a fuzzy set to different degrees. And that degree, we term that one as degrees of membership. So completely within a set is a membership degree of 1. And completely outside a set is a membership degree of 0. Okay, so later on, I'll be trying to show you a short video clip. And I hope it can be visible or you can hear clearly the video clip that I'll be sharing later on so that you can visually understand what fuzzy sets are. So degrees of membership must sum to 1, just like in your statistics, diba? So an item can be both A and not A to different degrees. A to a degree of point A and not A to point 2. So the maximum value for probability is 1. So when a degree of A is applicable of point A, of course, its negation A is point 2. Degrees of membership are even expressed with membership functions, and we do have different types of membership functions. And range of values a variable can take is called the universe of this course. So I will now be explaining to you the different types of membership function. But before that, let me clarify to you that a membership function describes the degree of membership of a value in a posse set referred to as a membership function. Also, we term this one as mu of x, where x is the value being pacified. So we have different types of membership function, and it also depends on the applications of your problem that you are trying to solve. What specific membership function are you going to use? First common example is the singleton. This singleton membership function, as you can see, we have here an x variable, and the y variable is the membership degree. And the membership degree is from 0 to 1, and the variable x is from 0 to 10. So when your value falls under this, which is 5, then the membership function or the membership degree for this membership function singleton is 1. However, when you put the value here, say for example around 7 or 8, this one, therefore the membership degree is 0. So it's just a matter of 0 and then 1 for this example. So this is the passes set or the rule that you already set, and make in your example here, we set the value of x as always 5. So therefore, if an input was provided by the user which is not equal to 5, then the degree of membership is 0. And if the value is equal to 5, then the degree of membership is 1. So that is easier for singleton. So this is actually the equation that we can use for singleton relative to my explanation. Another one is rectangular. So in rectangular, as you can see, the shape is actually a rectangle, okay? So in this example, we set the value of the membership function from 3 to 7. And again, the membership degree is from 0 to 1. So it means that if you have values here which are 3 or within the range of 3 to 7, then the membership degree is 1. However, if your value there is from 0 to at least 2.9, then the membership degree is 0. Also for 7.1 to 10, the membership degree is also 0. So what matters here is the set membership function, the values that you considered in setting your membership function. So that will define the membership degree. And this is again the equation that we can use for rectangular membership function. Another common application that we can use is the triangular membership function. I actually use triangular membership function and also trapezoidal membership function. That's actually within the family of triangular membership function. So we have 3 in the family. We have the left shouldered, we have here the triangular, and the right shouldered. So the left and the right shouldered are actually similar to a trapezoid. So in here, we actually have 3 membership functions. So this is the first membership function, the second, and the third. So it's up to you. You can actually have 5 membership functions, 7, or whatsoever. So how are we going to determine here the membership degree? If we put here the value, say for example, which is 0.5, so it's somewhere here, therefore the membership degree is 1. But if we put the value of x, which is equal, say for example, to 7.5, so the membership degree is about at least 0.55 or 0.5. 0.55, okay? And then relative to y-axis, and then relative to x-axis, the value is around 7.2. So that is how are we going to read the membership degree depending on the type of the membership function that you will be using. So we have here actually the triangular membership function equation. Another common example of membership function is the Gaussian. So in the Gaussian, we can actually represent using this shape. And actually the concept there is actually the same. If you have the value here, it's the value of the membership degree is about 0.5 or 0.45. And then the x-axis is about 3. The value is 3. So same concept also, but most of the available membership functions that I read through and explored in IEEE, they make use of triangular, trapezoidal, and singleton. So seldom they use rectangular. Some make use of Gaussian. And this is actually the equation that we can use for the Gaussian. Another terminology after the membership function is the falsification. So what is now the falsification? Basically, it is a process of determining the degree to which a value belongs in a fuzzy set. The value returned by a fuzzy membership function. So most variables in a fuzzy system have multiple membership function attached to them. So what makes it novel is that you as the researcher, you are the ones defining your own membership function. I can still remember I have one publication and I created my own membership function template and I termed that one as Caldo's membership function template. So you can have your own membership function. So pacifying the variable involves passing the crest value through each membership function attached to that value. So similar to what we have in your subjects like logic circuits or discrete math, so fuzzy logic also applies and, or, and then not applications. So and is true if both parameters are true, or true if either parameter is true, not reverses the truth of argument. So I believe this is very common to everyone, and we as especially computer engineers, we actually make use of this one from time to time. So for the AND function, for the fuzzy logic, so we have here the truth table. So we have here two input variables, A and then B. And then, of course, we use the AND operator, A and B. So the value for A and B here is you can get a value of 1 when you have two values of 1 for A and B. However, for fuzzy logic, we use the minimum of the two arguments as the term. But actually, the operation of the AND in fuzzy logic is the same with the AND operator in your logic circuits or discrete math. So what does it mean? So you get the minimum between A and then B. So what is the minimum between A and B? So it's still 0. Minimum of 0 and then 1 is still 0. Minimum of 1 and then 0 is 0. Minimum of 1 and 1 is 1. Okay. So we make use of the term minimum in fuzzy logic, not the multiplication application or operation. For the OR function, so similar again to our logic circuits, so we use A or B, and usually we only get a 0 value output once we have two input variables which are both 0. But in fuzzy logic, we use the term max. Okay, so what is the maximum value between A and then B? So it's still 0, 0 and 1, 1, 1, 0, 1, 1, 1 is 1. Okay, so this should be A and B. It's not C. Okay. So again, the application for our function is maximum. For the AND operator, it is minimum. So we use those rules in fuzzy logic. For the NOT function, still the same, it's just the reverses of the truth. When you have an input value of 0, it will become 1, and 1 will become 0. But in fuzzy logic, we use 1 minus A, similar to probability. So what is the opposite of 0? It's actually 1 and 1 is 0. So we use those three operators, and, or, and not. That's why switching to fuzzy logic is not that difficult once you have good rules with you. Output of fuzzy logical functions are the same as crisp functions, so just calculated differently. We handle the degrees of truth rather than obsolete truths. The basis of fuzzy rule-based systems. Ayan. So we'll now be talking about how are we going to formulate the fuzzy rules. Similar to your truth table, if you can remember, you also have your antecedents and consequence. So antecedents, basically, these are the input conditions, and the consequence, these are just the outputs. So it both deal with partial truths. Antecedents match fuzzy sets. Consequence assign fuzzy sets. Fuzzy rules can have weightings from 0 and then 1. And the importance of rule is very important, and we usually set that 1 to 1. So usually for the membership function, we use range from 0 and then 1. But you can actually use actual values. If, for example, you would like to deal with temperature, so you actually use 24 degrees, you actually use 35 degrees or 40 degrees. It's okay. However, in order for you to fit that in the other variables that you'll be using in your fuzzy logic, say for example, you also have relative humidity, you needed to normalize those values. So what does it mean when I term normalize? So 0 to 100 is also the same with 0 to 1. So therefore, if you have value of T as input from the user, then it's actually equivalent to 0.5. So that is actually the normalization process. You can actually program that one as well. I will give now a short example. How are we going to apply fuzzy logic? And then later on, I'll be playing a short video clip so that you can realize visually how fuzzy logic works. So this example is related to restaurant tipping example. So say for example, you will be taking orders from a specific restaurant. So what will make you decide whether you will be giving a tip or not? So that is the problem that you are trying to solve here. The antecedent variables that you needed to consider are the following. You need to consider the quality of service and the quality of food. So basically, these are the two main items that you need to consider when you would like to give tips. So if the service is good and the food is good, maybe you can give a better tip compared if the service is poor and the quality of the food is very poor as well. So of course, you will not also give a tip. And the consequent variables, of course, is the tip because that is the output that we are trying to achieve. Now, I have here the fuzzy rules that I have set. I linguistically classify the service. The service can be poor, can be good, and could be excellent. Okay, so I only have 3 linguistic classifications. I even use the universe of discourse from 0 to 10. So it's not yet normalized. Again, when you normalize, you use 0 to 1. So in this example, the universe of discourse is from 0 to 10. And the membership degree is always the same from 0 to 1. So you create your rule here, just like this. Okay. This is one membership function using Gaussian, another membership function, and another membership function. So this membership function was created given the knowledge about service relative to poor, good, and then excellent. Another membership function can be created relative to food because we have 2 antecedents to consider. As I have said, we have the service and the food. The first one applies for the service and the other one applies for the food. In this example, I have used trapezoidal for the rancid and delicious and triangular for the good, but I actually have 3 as well. Take note here that the universe of discourse is from 0 to 10. And actually the same with the service from 0 to 10. It should always be the same. If not the same, you have to normalize them. The food I classified as rancid, good, and then delicious. Now we already have the membership functions. So we use the Gaussian, we use the trapezoidal, we use the triangular, and then we identify them using linguistic classification. The next thing to do is to set the rules. And then after setting the rules, you can get the consequent or the output. So now I have here the fuzzy rules for the tipping. Okay, so this now applies to the output because we already have two input variables, service and then food. Now we have here another triangular membership functions for the tip, which is the output. For the output, the tip percentage is used from 0 to 25%. So say for example, the assumption here is that say for example, you have 1,000 pesos. So you will only have to multiply your 1,000 pesos with the classification here that you can get when you already set the rules after putting the values in the rule-based system that you created. So in this example, we have your cheap, average, and then generous. So it only means that your tip is cheap. If the tip is cheap, so you can give only around 0 to 10% of your money. And then if average, around 7.5 to at least 17.5, that is the range. And also for the generous, about 15 up to 25%. Okay. So this is setting these fuzzy rules should have a basis or reference. Definitely, if you can't use 0 to 100%, so it's beyond the normal that you give 100% of the tip. Okay, so usually you give only from 0 to 25%. Now I will be setting now the rules relative to our input variables, which is food and then service and then output, which is cheap. Okay, take note of these fuzzy rules. So this is the rules that we set for tipping system. If the service is poor or the food is rancid, then tip is cheap. Make sense? Of course, the service is poor and the food is not that good, then of course you can give, but it's cheap. If the service is good without yet considering the food, then the tip rather is average. However, if the service is excellent or the food is delicious, then the tip is generous. So that is how are we going to set the rules in fuzzy logic. So you now already have a problem-solving control methodology to solve this problem related to restaurant tipping. So that's actually one example, but you can actually apply this one to any other application or field that you would like to use. Another consideration is to use the fuzzy inference. So it infers fuzzy conclusions from the fuzzy facts and matches facts against fuzzy antecedents. So we actually have a formula for the fuzzy logic, for the fuzzy inference. And as I have said, you actually don't need to memorize the formula for the fuzzy inference, the center of gravity, because in the MATLAB fuzzy logic toolbox, you can actually use two different fuzzy inference system. And the name of the FIS systems are Sade, Mamdani, and Takagi Sugeno. Sometimes we call that one as Mamdani style and then Sugeno style. The only difference is that in Mamdani, you actually use different types of membership function, but in Sugeno, for the output, you only use singleton. So that's actually the main difference between the two, but they actually use center of gravity formula to compute for the results or the output. If you will derive the membership function yourself, you can actually do that. I even do that as well. but it will require you coding the fuzzy logic from the scratch, just like what I did for Verilog, the HDL, C++, Excel macro program, and even Arduino IDE. In some cases for Arduino IDE, you can use library of fuzzy logic. But if you will be using fuzzy logic toolbox in MATLAB, so it's very easy. So you can actually click and drag there and you can get the results already without rewiring or without deeply understanding the formulas being used in fuzzy inference systems. And then with the FuzzyPy, as I have said, how are we going to the FuzzyPy? We use a formula of center of gravity and the mean of maxima. So this is the formula for the center of gravity for the falsification method when you are trying to get the results. Okay, so before I proceed with a comparison between fuzzy logic and neural network, as I promised, I'll be showing to you a short video clip related to fuzzy logic, and I hope it can be heard in your side. I will be playing it now. Sorry, can you hear the video? Can somebody voice out?
Not yet, sir.
Can you?
Di ko
Mahina,
rinig,
sir.
sir. Sir,
Hello?
wala po.
Sir, wala po, sir.
Okay, sorry. How am I going to do that? Wait, sorry. Share a sound. Let me know if you can hear, huh? Thank you.
Let's see how an intelligent robot tackles the
Okay na po, sir.
Okay, I will start again. Thank you so much.
Welcome. In this video, we talk about fuzzy logic, a tool engineers and scientists use to add intelligence into robots.
Sorry. Hindi naman nakashare yung video. Nakashare yung sound, pero
Naka-PowerPoint pa rin po.
Okay. Teka. Thank you for commenting on that, ha. Wait lang. Paano ba yon? Stop recording. Naka-PowerPoint pa din.
Hello,
Okay.
Sir Caldo.
Yes, hello, sir.
Yeah. You can, there you go. Yeah, we see it now.
Okay po. Thank you, sir.
All right, very much welcome po.
Sir,
After 5 minutes.
Can you hear? Before I repeat?
Unfortunately, the eggs sometimes turn.
Can you hear it? Okay, thank you. Thank you, sir. Okay po.
Welcome. In this video, we talk about fuzzy logic, a tool engineers and scientists use to add intelligence into robots, video games, and even in household appliances. Fuzzy logic is fantastic, as it solves complex problems by using simple rules. Let's see how an intelligent robot tackles the challenging task of boiling an egg using fuzzy logic.
Sir, hindi po naka-share.
Boiled eggs.
Sorry.
Hindi po
Ay,
nagpa-play ang video, sir.
Sir, hindi po
Ay.
nakashare ang screen. Sound lang.
oh, sorry. Parang kanina nag-okay na, hindi pala. Sorry po. Okay, sorry, where is it? Stop share. Ulitin ko na lang.
Chef for
Kita na ba?
some tips.
Wala po,
Mike
sir.
noticed
Wala po,
Jane's
sir.
robot.
Yung pinaka-files ko nakikita.
Yung sorry sir ha. Eto, nakikita niyo po yung screen ko?
Opo.
Eto sir yung file.
Oo nga. Pero hindi po ata siya
Hindi nagsishare screen.
yung pinaka-video.
Audio lang.
Saan kaya dito sir yun? Sorry naman.
Maybe you can try po i-share yung whole screen nyo. Then max out nyo na lang po yung pinaka-video.
Full screen. Pero ba't yung PowerPoint okay naman? Pag yung PowerPoint visible naman po, ano?
Yes.
Po.
Yes.
Pero nung nag-switch na ako, ayan, yung mga nagalaw-galaw ako right now, eto, hindi pa rin kita.
Hindi po, PowerPoint
Hindi
pa rin
pa.
po.
Okay. Sige po, anyway, i-try ko na lang ding i-send muna kay Brian and then i-continue ko muna yung discussion and then if mapi-play later on ni Brian, I would appreciate it. Okay lang ba?
Okay po.
Okay. Sige. Ay. Oh, too large. Okay. Anyway, sige po. Pasensya na po kung hindi natin mapiplay yung video right now. But anyway, I'll be continuing na lang the discussion. Yung content lang naman po ng video for your information everyone, basically is related po siya sa egg robot making using fuzzy logic. So in that example, we have there the chef or the chef as the expert, and then somebody asked that expert on what particular formula she will use in order to formulate an egg boiling robot. So that's one example. And another video that I have is about the basketball. When you decide whether a person is good enough to play basketball or not, or whether a person should consider boxing instead because of the tall issues. Okay. So let's now proceed to the fuzzy logic versus neural network. So as I have said earlier, so another type of computational intelligence is the neural network. We actually have different types. Another discussion could be related to artificial intelligence. Another might be related to genetic algorithm. But I would only try to explain here the difference between fuzzy logic and neural network. I actually even tried to implement different research works using fuzzy logic and neural network and try to compare them. And I get same results actually. So how does a neural network work? So the common thing about fuzzy logic and neural networks, they are both modeling using the human brain. So you actually needed to have some decisions through our minds. and then it both used to create behavioral systems. And on this right side, for neural network, it's more of mimicking how our neurons work. So that's why the term there is neural network. So we actually use the weights and the sigmoid here to come up with the results for the neural network. Unlike for the fuzzy logic that we use rule-based systems. We actually have different algorithms under neural network, just like the backpropagation algorithm, supervised learning algorithm. So those are different algorithms related to neural network. In terms of complexity, so I think it's more complex to use neural network compared to fuzzy logic because you needed to consider a lot of algorithms compared to fuzzy logic. However, if you will be using neural network toolbox in MATLAB, it's actually very easy to implement neural network as well, similar to fuzzy logic toolbox in MATLAB application. So this is an example of fuzzy logic in control systems. So fuzzy logic provides a more efficient and resourceful way to solve control systems. Some examples are temperature controller and the anti-lock brake system or the ABS. So here we have here a temperature controller example. So we have here a problem. Change the speed of a heater fan based off the room temperature and humidity. So the idea there is the output is the fan speed and the input variables are the temperature and the humidity. And then the linguistic classifications that we use for humidity are low, medium, and then high. However, for the temperature, we make use of the cold, cool, warm, and then hot. You will decide the linguistic classifications. This is just an example. You can use 5 for the humidity. You can use 7 or 10, whatever for the temperature. And of course, it will defend the output for the fan speed, which is your consequent, will depend on the rules that you will be setting relative to your input variables. So in this example, what we are trying to explain here is that if the temperature is cold and the humidity is low, then the fan speed should be medium. For this example, if the temperature is hot and then the humidity is high, then the fan speed should be 0. In this example, if the temperature is cool and the humidity is medium, then the fan speed should be low. So again, for this temperature controller, you need someone expert to give you the rules when you have two input variables, temperature and humidity, what will be the fan speed. So I believe that most of your research works applies control systems methodology. So you can actually apply this fuzzy associative memory matrix table for your implementation if you will be using fuzzy logic. What are now the benefits of using fuzzy logic? So as you can see here, the workflow is much more simpler and simplified or optimized when we use fuzzy logic. This is the traditional approach that we are using. And I believe that most of us, especially our teachers and me in my thesis works as well before I graduate CPE, I follow these steps. So you understand the physical system and control requirements. So you will actually do that as well, even in fuzzy logic. So there's no problem with that. Sometimes you will develop a linear model of plants, sensors, and actuators, especially if you will be controlling something and you actually have some feedback system. And you will be also determining a simplified controller for control theory. If you can still remember your control systems, you have proportional integral, proportional derivative, proportional integral derivative, or the PID controller. And then you will develop an algorithm for the controller or a mathematical model. And then you simulate, debug, and implement and design. So that is the traditional approach that we are actually following. But using fuzzy logic, you don't need to do higher mathematics or mathematical modeling. So you do the design using fuzzy rules. And then you simulate, debug, and implement the design. That's it. And you can get almost same results. Not that accurate as this one, but you can actually control relative to your expected output. So this is an example of the anti-lock brake system or the ABS. So you can actually implement fuzzy logic for this application because this is nonlinear and dynamic in nature. I would suggest if the problem is just linear, so you don't need to use any more fuzzy logic. You can directly use a certain formula for that purpose. But if non-linear and dynamic in nature, and it's so hard for you to formulate or create an equation or formula or a mathematical model to solve the problem, then I suggest you use fuzzy logic for your convenience. So we have here we have here the inputs for the Intel fuzzy ABS. We have the brake for WD, ignition, feedback, wheel speed. So basically, these are just the data inputs. And then you have the main program here to control for the process. How are you going to control your inputs, or how are you going to transform your inputs into its desired outputs? It's just like an IPO model here. So we have here for the main program, you use the fuzzy logic. The inference engine, it could be Mamdani, it could be Sugeno fast inference system. And then we have two outputs, the PWM and the error dump. So it's actually possible also to have two outputs or three more outputs, but commonly we only use one output. But for this example, of course, we need to consider the PWM and the error dump. And in some cases, it will be feedback pa to the inputs. Okay, just like what I did for the DC-DC back boost converter system. I'll be showing that one later on. Fuzzy logic can even be applied in other fields, like in business or hybrid modeling or expert systems. I can still remember I have one fuzzy logic application. I predict and assess whether board courses in engineering will pass the board exam or not. So that's one fuzzy logic application I did. And then hybrid modeling is just a combination of automated and manual. So a hybrid modeling example is implementation, say for example in Arduino microcontroller. So you use Arduino for the hardware part, but inside the Arduino, when you do your control, you don't use the PID anymore. You use fuzzy logic for the implementation purpose. So we call that one as hybrid. And expert systems for computational intelligence purposes as well. So as a conclusion, fuzzy logic provides an alternative way to represent linguistic and subjective attributes of the real world in computing. It is able to be applied to control systems and other applications in order to improve the efficiency and simplicity of the design process. I would like to give you some idea here, some approach, whether you are going to use fuzzy logic or not. Because maybe this fuzzy logic may not be applicable in your current work or current research work or the research work that you would like to do in the long run. So that's why you needed to understand how are you going to approach fuzzy logic. So this is just an assessment as to whether fuzzy logic is applicable for the given application. Evaluation criteria. Has fuzzy logic been previously applied to a similar application with success? Even in your defense, your panel members will always ask you, do you have relevant studies that will support your research work? Even your professors will ask that because that is very important. Because if you are trying to solve something that is not yet known to anybody, then it will be a suicide in your part. So of course, you have some similar application with a relevant success. What is good example of this? One good example is when I do a research in Taal Lake. I assess the quality of the water there using fuzzy logic. So I don't have any reference in the Philippines doing that, but I found one reference. I saw that in IEEE paper, and it is applicable to a river. So they apply that one to assess the quality of the river, the water quality of the river. So I use that as reference to do the fuzzy logic. So you have some reference for this purpose for it to be successful as well. Is it a multivariable type control problem? As I have said, kung ito po ay non-linear, so you can use fuzzy logic. But if you only have two input variables and then ano pa siya linear, so you don't need to use fuzzy logic anymore. It should be multivariable type. Do operators and engineers possess knowledge about any relevant interdependencies of the process variables? Going back to my example, when I study about the quality of the water in Taal Lake, I'm not an expert in terms of water quality assessment, right? So what I did there is I go to BFAR in the fisheries school there, and then I interviewed someone, and then I get idea from them how am I going to create the rules for my fuzzy logic. Can further knowledge about the process behavior be gained by observation or experiments? I even did this one. I get the measures, the current measures that I have right now relative to dissolved oxygen, relative to ammonia, relative to pH, and so on, turbidity. So I gather all of the experiments that they did, and then I use that as an input to my fuzzy systems when I try to do the testings and fine-tuning of my fuzzy logic system. Is it difficult to obtain a mathematical model from the process? So in my example, yes, definitely. There's no direct formula to assess the quality of the water. You needed to do some mathematical model for that purpose. And fuzzy logic is an easier tool compared to using high-level mathematics for that computation. Okay. So usage. So next is you will define the control objectives and criteria. So you need to understand what am I trying to control? What do I have to do to control the system? What kind of response do I need? What are the possible or probable system failure modes? So you need to consider all of those steps along with the relationships of your input and output. You need to choose the minimum number of variables for input to the fuzzy logic engine. As I have said earlier, for my example, you have different water quality parameters, hundreds. But you only have to select what are the most critical water quality parameters that you can consider in your monitoring. So especially also applicable in your research work, so you can actually choose the minimum number of variables. Then you use the rule-based structure of the fuzzy logic. As I have said, we have the fuzzy associative memory matrix or the FAM table. You need to break the control problem down into a series of rules. And then from there, you can now create the membership function. You can use triangular, trapezoidal, Gaussian, define the meaning or the values of the input and output terms used in the rules. And then after that, this is the challenging part. You need to test. Does it fit already your output? You need to evaluate, you need to fine tune, and then retest and retest until such time you already have the good rules and good combination of your membership functions. This is an example of the rule matrix. As I have said earlier or presented earlier, you can create something like this one. It's just a table. You have the two input variables here and the output here. So fuzzy logic deals with uncertainty. If you're uncertain, how are you going to solve the problem? Then fuzzy logic is best for that. It allows degrees of truth, allows partial membership in sets, fuzzy membership functions that describe degrees of membership in fuzzy sets, and many different types of membership function exist. So it's up to you what specific membership function are you going to use. So again, pacification is just determining the degree of membership. When we determine to what specific degree this particular passive value belongs, so that is pacification. And fuzzy logic extends Boolean operators to handle partial truths. Remember, we have the AND operator, the OR operator, and the NOT operator. Fuzzy rules match fuzzy antecedents to fuzzy consequence. So that's why we have the fuzzy associative memory matrix or the truth table for that purpose, and the rule-based system. Degree to which antecedents are true determine the degree of support. And fuzzy logic functions are used to determine this one. Fuzzy inference involves calculating an output fuzzy set. So again, we have two different fuzzy inference systems. Ma'am Dani, and then Sugeno style. So again, Ma'am Dani makes use of different triangular membership functions for the output. However, for the Sugeno, we only use singleton for the output. So these are the two common composition methods, but the most commonly used method to compute for the crisp output value is the center of gravity formula, or the COG. This one, the center of gravity, or the COG. Okay, so I think I'm done with the first part, but I would like also to share with you some research endeavors that I did. It will not take any longer anymore, so that I can entertain questions if you have any. So I'll be sharing you some of the Logic publications and presentations that I did, some research works that I already did, so you can get some idea how did I use or implement this one. Then after this one, I'll be showing to you some diagrams that I've used in my presentations abroad. So this is actually my very first research work related to fuzzy logic. This is very close to my heart. So this is one of my coursework when I'm still studying in De La Salle for my master's in ECE. So I presented this one in an international conference, TenCon 2012, held in the Philippines. Fortunately, in Cebu, Philippines, so it's easy to get there. So it's sponsored by DOST and ERDT scholarship as well. It was entitled Fuzzy Logic Control of Water Quality Monitoring and Surveillance for Aquatic Life Preservation in Taal Lake. So just to give you some glimpse or idea about this topic, so as I have said earlier, I go to the BPAR. I interviewed some experts there, some scientists, and then I determine the rules for the identified critical water parameters. And then I was able to get or assess the quality of the water using the fuzzy logic. So triangular membership function is the membership function that I have used. I even derive the membership function. So I call that one as Caldas membership function template. Another one presented in the 8th ERDT conference at Radisson Blu Hotel is water quality assessment again using backpropagation neural network for aquatic life preservation in Taal Lake. So the idea there is I'm trying to compare my results using fuzzy logic with neural network. So this time I use backpropagation neural network. So it's a different session. It's so wide or so broad to discuss to you about neural network. But I have used here neural network toolbox in MATLAB. And then when I compare the result of the backpropagation neural network and fuzzy logic, both for same application, I get same results. Next is, it's a very simple example about fuzzy logic derivation and simulation of a 3-variable solar water heater using MATLAB fuzzy logic toolbox. So this time I have used naman ang MATLAB fuzzy logic toolbox. So later on I will be trying to show you also how MATLAB fuzzy logic toolbox works, how to create that one. I presented this one in DLSU Manila, so 6th International Conference on Humanoid Nanotechnology, Information Technology, Communication and Control, Environment Management 2013, or HNSM. It's an IEEE paper. It's an international conference as well, presented in De La Salle. Okay, another one. This is actually one of the work of my advisee. So this is an application in the medical field. Type 1 fuzzy logic classification of pain severity or pain assessment. So the idea there is you assess how painful it is, how severe the pain it is. So we use fuzzy logic for that purpose. Also presented in HNSM 2013 by my student. Of course, I'm with him. Next, this one is I presented in De La Salle University, Dasmariñas, a research week. Way back 2013, I assessed the passing of engineering board courses in LPU Laguna using fuzzy logic technology, because during that time we have very low passing rate for ECE and EE in LPU Laguna, so we needed to do some assessment. So we use fuzzy logic for that purpose as well. Next is the simulation of fuzzy logic controller for DC-DC back and boost converter in 3 programming platforms presented in 14th APMs in Cebu, Philippines International Conference as well. So this one, I apply fuzzy logic for DC-DC back and boost converter. And then in 3 programming platforms, because I implement using VHDL, using DevC++, using Excel macro program, and then I compare the results and the results are the same. Next, this one is my very first international or my very first presentation abroad with my advisor. This is actually my thesis for my master's, design, development, and implementation of a fuzzy logic controller for DC-DC back and boost converter in an FPGA. So I implemented fuzzy logic in FPGA for DC-DC back and DC-DC boost converter. So presented in Nha Trang, Vietnam, available also in IEEE Explore. If you can search there, my research work, you can download this one as well. Another is fuzzy logic simulation of DC-DC boost converter using MATLAB fuzzy logic toolbox. So I have used MATLAB fuzzy logic toolbox to simulate boost converter for DC-DC. I presented this one in Jeju Island, Korea in 2014. This one published already in an international journal. So I just published this predictive assessment of passing engineering board courses in a journal. I even presented that one in international conference in Jeju, Korea, along with this research paper. And then another I presented in PAASE about FLC-based indoor air quality assessment for ASHRAE standard conformance. So this time I use fuzzy logic for indoor air quality assessment, and then I have reference from the ASHRAE presented in De La Salle also. Another one, this is actually a product of my advisee, electrical engineering students, and then their thesis work is related to ground grid integrity testing. And then I help them using fuzzy logic on how they are going to assess the integrity of the grounding system using fuzzy logic. So it was presented by them as well in De La Salle. So I guided them in their presentation. And then I also presented in Tokyo, Japan. This is a prestigious conference with Springer publication, FLC-based indoor air quality assessment for ASHRAE standard conformance and ground grid integrity testing. I presented also this one in Tokyo, Japan. And then this is the publication in Springer, lecture notes in electrical engineering. So if you can download also, you can download my research works there in Industrial Engineering, Management Science and Application, copyright 2015. Another presentation I did is in Penang, Malaysia, FLC-based renewable wind energy viability assessment in Central Luzon, Philippines, one of my coursework in Adamson University. So I presented this one. I assessed the viability of implementing wind energy in the Philippines, especially in Central Luzon using fuzzy logic. Okay, so now I'll be showing to you some outputs about some researches that I already did. Of course, I will not be explaining this one by one. So this is my keynote speech in Bangkok, Thailand, when they invited me to be the keynote speaker. And then I presented this research work. So just to give you an idea related to fuzzy logic. So this is the block diagram. How did I do the fuzzy logic controller? So we have here the knowledge base, and then the decision making, the depacification, and then from here on, I have here the DC-DC converter, and then I have an error amplifier, an error corrector, and then it will be feedback again to the system until such time that I was able to get correct output or voltage values for my back and then boost converter, because that is what I'm trying to solve. Yes, hello?
Hindi po naka-present yung block diagram.
Okay. Sorry. Is it visible now? No?
Not yet.
Not yet. Thank you. Thank you, Hap. Thank you for batting in. Let me know if it is already visible. Oh. Is the slide related to design and development implementation already visible?
Not yet, sir.
Okay, okay. Anyway, I'll be sharing again. Sorry for that. Okay. Now, I think it's visible.
Yes,
Is it?
Yes, sir. Yes,
Okay.
sir. Yes.
So, sorry for that. And thank you for batting in, ha? Okay, so this is design, development, and implementation of fuzzy logic controller for DC-DC back and boost converter in an FPGA. So, this is one of my keynote speech in Bangkok, Thailand. So, I guess I have students here doing computer system architecture. So I use VHDL here, not Verilog. But you can actually use Verilog also for implementing fuzzy logic controller. And since I will not be explaining it thoroughly, I will just be giving you idea what is the desired output for this particular project. So specifically, I describe the fuzziness in DC-DC back and boost converter. So when you use the term fuzziness, I created actually my own membership function to compute for the DC-DC back and boost converter. And then I presented the derivation of fuzzy control rules. How do I set the basic converter circuit for the back and boost converter using fuzzy logic? And then I will also develop modeling variable for DC output voltage using MATLAB Fuzzy Logic Toolbox. Dev C++ or C++ or C, you can use Fuzzy Logic using this. Excel macro program to my students in OOP. I even use Fuzzy Logic using Excel macro program for back and boost converters. And then I develop a hardware model of Fuzzy Logic controller for variable output voltage DC-DC back of 3.3 volts down to 2 volts input voltage levels to 1.5 voltage output. So it means I only have input values from 3.3 to 2 volts input, and then my target for the back converter is to lower down the voltage and get an output of 1.5 when you have these two input voltage levels. So that is what I'm trying to control. And for the boost converter, I have 3.3 to 5 volts input values, and then my target is to get an output voltage of 6.6. And then I will compare and contrast the performance of the fuzzy control system in 3 different programming platforms, implement an FPGA-based fuzzy controller for DC-DC converter. Because I also have a hardware here, I implemented the fuzzy logic DC-DC converter in an FPGA board. I think I used Vertex 5 during that time. And then I test and evaluate the performance of the fuzzy control system in terms of load, white LED, and line regulation. I also have back converter circuit or boost converter circuit for me to check on this. Okay, and now, so that you have the idea, I'll just be showing you this is actually the flow chart of the project. So I actually use Xilinx ISE to simulate in the model sim. And then when I already get the results, then that's the time I download in an FPGA board. And this is the fuzzy logic controller part. How did I implement this? I coded this one in VHDL. And then this is the one that I'm explaining earlier about the block diagram of the fuzzy logic. This is the fuzzy logic controller. In the fuzzy logic controller, of course, it requires inputs from the user. And in this example, what makes it different is that it has already a feedback, an error amplifier, an error corrector, and it will be feedback again to the input. And of course, once you feedback to the input, it has an effect on the output as well. So that is the very crucial thing about this one, because I needed actually to fine-tune the voltage output while changing the feedback in the input. Okay, and then these are just the input parameters that I have used for the back converter and the boost converter, voltage error and the change of error, I have two input variables, but these are feedback. And then the output are negatively big, negatively small, zero area, positively small, and positively big. This is an example implementation that I did using MATLAB Fuzzy Logic Toolbox. In MATLAB Fuzzy Logic Toolbox, you can simply click and drag this one. These are the input variables, and these are the membership function. You can already draw that one, and this is my output. I use Sugeno style. This is just a singleton. So for my duty cycle. And then this is basically a trial test when I do for the back converter, and this one is a trial test when I do for the boost converter. So the output is the duty cycle, and the duty cycle will be feedback again to my input. This one is the fuzzy associative memory matrix that I've created for the boost and back converter. So this is the rules that I've created for the error and for the change in error, both for the back and then the boost converter. This is the implementation that I did, the simulation result using C++. Okay, so this is for the boost converter and this is for the back converter. So you can see here the number of iteration. I can already get an output of 6.64 only for iterations. Can you imagine how fast it is using fuzzy logic? This one is for the back converter. I only need 7 iterations to get desired output of 1.51. Okay, so this is the assessment, the checking of the results for the Dev C++. Just the result. This one is for the Excel macro program. I created an Excel macro program, another tool, this one. And then you can just input here the value of, you can select whether boost converter or back converter, and then you can get the results there, and it can already judge whether it is beyond the limit or not. Okay, I even created an add-in for this purpose to generate the DC-DC binary generator and how to initialize that one, because we are talking about here about binary strings, so of course decimal is different from binary, so you needed to do some conversions for that purpose. It's actually difficult. And then this is actually the RTLS schematic that I did. This is the high level design for my students, the top level design. So I have here the error generator, the normalizer, the fuzzy final, the back and the fuzzy final 2, and the sample corrector. This one is for the boost converter. Of course, I did not include anymore the low-level design because the circuit is too complicated and the VHDL code is very long as well. And this is the sample setup when I implement in the FPGA board. Of course, I saw the results using the oscilloscope and some back-end boost converter circuit here. And then I experiments and analyze the results there. And of course, I got favorable results. I even compared using correlation coefficient between the different programming languages, and they are perfectly correlated with each other. And then I concluded already the research work. Okay, so another example, maybe this is the last. Okay, so another example is about FLC-based renewable wind energy viability assessment in Central Luzon, Philippines. This is also interesting because my reference there is I actually read through a lot of research works available related to wind energy. And then Central Luzon is one of the very potential for wind energy application in the Philippines. So what I did there is I present the relevant literature reviews on wind energy resource. I develop and illustrate a model of fuzzy logic for representing viability of wind resource and construct membership function and derive fuzzy control systems for renewable wind energy viability analysis, and then I simulate the performance of PASI system. I will not go through with the literature review anymore, it's very long. And then based from the review of literature that I did, that's why it's very important. That's the idea there that I was able to create a wind viability assessment using the wind resource density, other wind resource parameters, the site-related criteria, and then these are basically the linguistic outputs that I've set. So this is an example of the Sugeno style FIS for wind viability analysis using MATLAB Fuzzy Logic Toolbox. This is the triangular membership function that I have created. This is the output. And these are the rules. So you can actually use rule editor in MATLAB Fuzzy Logic Toolbox. It's very easy. And then I have here the scoring sheet of selected sites in Central Luzon because I needed to compare whether my predictions are acceptable or not. This one, so as per assessment, so very good for Sual, Pangasinan, and Caranglan, Nueva Ecija. However, good only for Sampaloc, Rizal, Caliraya, Laguna, Pantabangan, Nueva Ecija, and Puncan, Digdig, Nueva Ecija. I did not go there anymore. I just get relevant literature. And if you will be implementing wind energy, we suggest, or I suggest, you use or you do implementation in Sual, Pangasinan, and Caranglan, Nueva Ecija because the score in the linguistic classification are very high. And these are just simulation results using the rule viewer in MATLAB Fuzzy Logic Toolbox again. And I just concluded. So I actually have 216 PASE rules in order for me to get the optimum results and fine-tune results for this wind viability assessment in Central Luzon, Philippines. Okay. So I think that would be all for my side. Thank you again for listening to my talk and sorry for some inconveniences. So if you have some questions, I would like now to give the floor to our moderator or to our advisor so that we can facilitate questions from your side. Thank you again and God bless us all.
All right. Thank you so much, Engineer Caldo, for that
Thank you, sir.
wonderful talk. Guys, if you have any questions, feel free to post it on the chat box since we do have a couple of minutes left. If you have any questions, feel free to post it on the chat box so Ms. Engineer Caldo can be able to view it for him to answer those questions. Don't be shy, guys. If you have any questions, feel free to post it now since we do have a couple of minutes left. All right. I don't see anyone posting any questions. I think Engineer Caldo was able to discuss it thoroughly and clearly in reference of introduction to fuzzy logic. I know some of the participants right now, the main reason that they joined this specific webinars, Engineer Caldo, is they don't have any heads up about fuzzy logic. Even me on my end, to be honest, I don't have any um, idea about the fuzzy logic, and it's not further discussed throughout if through our education through college. Fuzzy logic is not even discussed, right? It's just an heads up. So we're truly grateful and thankful to Engineer Caldo for um, being one of our resource speaker to further discuss the introduction to fuzzy logic and its application. So right now, let's go ahead and proceed with the awarding of the certificate. Allow me to read the certificate. Hold on. Trimex Colleges, Scopes, together with engineering department, this certificate is awarded to Engineer Rhino B. Caldo in grateful acknowledgement and sincere appreciation for a valuable service rendered as resource speaker in the webinar entitled Introduction to Fuzzy Logic and Its Applications, with the team championing professionals in the new normal, the world of computer engineering. Hereby signed by Dr. Rito A. Camigla Jr., our VP for Academics and Student Services, and our Engineering Department Head, Engineer Kervin R. De Mesa. Engineer Calder, you will be receiving a PDF copy of this. I will be sending out to your email.
Thank you so much, sir, and thank you so much to everyone for attending today's webinar. God bless us all.
All right. Thank you so much again,
Thank
Mr.
you, sir.
Uh,
Thank you.
Engineer Caldo. Hopefully, we are able
Thank you
to
po.
Thank you,
see
sir.
you for further webinars that we'll having in the future. So, yep. Since we do have some couple of minutes left, guys, here's what we're gonna do in reference of the raffle. What we're gonna do is we'll go ahead a separate live Facebook live, and we'll be posting it to our Scopes page, group or GC. Then, if ever some of you are not able to view the Facebook live, all the winners will be contacting you directly to the information on the registration. We're able to get your email and your phone number. We'll be the one to contact you directly. So we will have five winners, and each one will be getting 200. It's either through Eload or through Gcash. So it's up to you guys. We'll be contacting you about that. So, and again, to all the participants, thank you so much for participating. And would like to call on our head engineer, Kervin De Mesa, for any words, sir.
Okay, so good morning. Can you hear me clearly?
Yes,
Yes,
sir. Loud
sir.
and
Yes,
clear.
sir.
Yes,
Good
sir.
morning,
Hi,
sir.
so first and foremost, allow me, Engineer Reynald Caldo, for his valuable insights and giving his valuable time actually for us to something new. Basically, of course, it will be a helpful tool for all of you, specifically for those having their proposals or research during this particular pandemic. It will be a helpful for all of us. Even though, of course, in professionals, we know the puzzle logic, but for those students, of course, in some of the curriculum are not part in terms of having the puzzle logic. But basically, it's one of the most vital part and to be created in order for you to propose system that can be beneficial for the society. And I would like also to thank each and every one of you for participating this particular webinar. We learned a lot, and you can also be a successful someday in terms of creating different systems that will be beneficial for all the companies or even in terms we are actually being having with, despite we are experiencing a pandemic. Still, thank you very much to all the officers. Of course, I would like to greet to all my students, to all my friends. Actually, we are having an international one. We also have special guests also from Canada, Montreal, Canada. Let's have Engineer Steven Arellana, and also to my friends and colleagues out there in Barcelona, Spain, who are also joining us in FB Live and here also inside the Zoom. And to all the students of senior high school coming from Santa Rosa, High School, and to all the students of senior high school coming from Santa Rosa High School, and for Vinian Valenzuela, if I'm not mistaken, from Cebu, also they're also messaging with me. They're actually watching, and from friends from Australia and Asian countries. Thank you so much also for watching and joining in this particular webinar. So to the scopes officers, and of course to all who participated in this event, thank you very much. May you learn something new from today as giving you insights and technical knowledge by our very own one of the faculty of the engineering. So thank you so much to all and have a great day to all. And of course, God bless us all and take care always, everyone, as we all know that the COVID having actually surged and of course in the Philippines. So hoping and praying for all of you to be safe, and of course despite pandemic, of course everything must be move forward. Everything must be moving forward. Keep doing a great things. So thank you so much, and see you by upcoming webinars. Basically, I think we have last three. For April 18 and the last two technical one, which actually be conducted by Aerobotica Philippines, which the two technical one for part one. Thank you so much to all of you, and of course, see you soon once again in the succeeding webinars. So I'm giving the floor for the moderator once again.
All right. All right. Thank you so much,
Thank you, sir.
Sir
Thank you.
De Mesa. And before we end this session, guys, I would like you to know that we'll having like a survey. This will be able to generate your certificate. So everyone should answer these surveys, guys. The link will be sent on the chat box right now, and also we'll be sending it to your emails. Kindly answer the survey. It's just a quick survey, guys, in reference of your experience during the webinar. And once you answer the survey, then we'll be able to generate your certificates. Then we'll be sending out to your email. So, guys, again, the link is on the chat box. Cal, if you can be able to copy the link, that will be great. That is sent by Mr. Manuel Garola. So, kindly um, check it out, okay? Click the link, answer the quick survey for us to generate your certificates. And your certificates will be given to you about 1 to 2 weeks, since we'll be needing to send it one by one for you, okay? So again, thank you so much for my team, the committee, for this today's webinar. Kudos, guys. Job well done.
So
And
let me inject for something. I would just like also to acknowledge all the presence of our faculty members, not only for for other departments. So thank you so much for supporting this engineering webinar. So still keep on supporting us, and thank you so much for your valuable insights and support to our students.
yes, thank you so much. And yeah, before we end this, I just would like to greet two of my team, Monique Tinido and Brian Cappadocia. Happy birthday, guys!
Happy birthday.
ECQ birthday.
Happy birthday,
so,
guys.
Thank
so
you.
yeah, again,
Yeah,
a
happy birthday, Nick
reminder.
and Brian.
Yeah, thank you, thank you, guys, and thank you
Kahapon pa yung
all.
birthday ko eh.
Belated happy birthday. So guys, again, the link for the survey is on the chat box. So if you can be able to copy that link, then you can answer it on the later time if you're too busy right now and you're on a hurry going into another subject, or if you have any appointment. So you can copy that link so you can answer that. Again, we'll be generating your certificates once you answer this survey, okay? So answering this link or this survey form is really important for us to send you your certificates, okay? All right. Okay. As per Sir Kel, we can do the raffle. So, Irene, are you still there?
Yes.
Okay, you can share the screen for a quick raffle. So again, we do have a couple of minutes actually till 11. So we can go ahead and do the raffle right now. Go ahead, Irene. You can share your screen.
Okay, wait lang po.
Okay. So again, we'll be having 5 winners. Each winner will be receiving 200. It's up to you if you'd like to be like an e-load or through your Gcash. We'll be the one to directly contact you, okay? And hopefully, guys are able to enjoy our webinar for today. And don't forget the survey link, guys, okay?
Okay na ba? Nakikita ba, Janelle?
Yep, it's visible. So you can now spin the wheel to win.
Okay, sige. Game
Oh,
na? Game
okay.
na, Janelle? Okay.
Our first winner is Irene Cal. Take
list
note of the winner.
completed for we have, or we already copied the updated registration?
Yes, sir. It is the updated one.
Edmark Paul Losterero.
Congratulations, Edmark Paul Lusterio. You'll be getting a 200 worth of Gcash or Eload. It's up to you. So kindly take note of that, Irene, okay?
Yes, okay.
Go ahead. Next one. We like the music, guys.
Maria Rachel Losterio.
Congratulations, Maria Races Lusterio. All right, let's go ahead and to the third one.
Ay, dapat nire-remove muna yung mga nakuha ng winner.
Sige, sige. Jomer Caburian.
All right. Congrats, Jomer Kaburian. All right. Next one. That will be our fourth one, right?
Eman John Garcia.
Eman John Garcia, congratulations.
Last one na ba?
Yep. And our last one will be, go ahead, spin that.
Kindly click the remove so that it will not be included in the list. Or
Vincent Manlesis.
All right. Congratulations, Vincent Manlesis. Okay. Again, those five winners will be contacted by our team and will be informing you guys on how you can be able to claim your prizes. Again, in behalf of Trimex College's engineering department, through our faculties, our head, our engineering council, and our committee, we would like to extend our thank you to all of you for attending our today's webinar with the topic Introduction to Fuzzy Logic and its application. And watch out for more series of webinars from the following weekends. So you can check out Trimix College's page or by contacting or doing PM to any of our engineering officers. Again, thank you so much to all of you for attending our today's webinar, and you keep safe, guys. God bless you all.
Thank you.
Again, guys, yung link ng survey, wag nyo kalimutan.
Thank you guys.
Okay, bye everyone. Thank you so much.
Thank you, sir.
Thank you,
Thank you,
sir.
sir. Thank you
Guys,
for
happy birthday,
participate.
Monique and
Thank you
Brian.
po.
Thank
Thank
you.
you. Thank you. Have a blessed day.
Thank you, Junel and team. Salamat. Bye po.
Thank you. Thank you.